Okay, so we're in 3.5 and we're going to be dividing polynomials today. And so they start us off with factoring because factoring is kind of like dividing if you think about it. So if I take this term, this expression here, x squared plus 7x plus 12, and I'm factoring it, I'm breaking it up into its multiplication parts, right? So you could see how factoring and division kind of are similar, but they're not exactly the same, which is why we have two different words for them. So we did this one. Let's see. Do you care which one we do? B, C, or D? Anybody care? Did you try this and then you wanted to try one of these? Which one did you want me to do? Or us to do, rather? All right, D. I agree. I was thinking about D too. Okay. So if I start with D, I'm gonna go through this whole thing here. So I'm gonna start with this little diamond first. And then I'm gonna fill in the box as well. Okay. So when I do this diamond, when I do this box, I'm going to fill it in exactly as I do it here. Now, if you're not comfortable with doing this, I definitely suggest pencil and paper or doing this on Desmos and writing this out. This is like one of those things that you're not going to learn it by watching someone else do it, for sure. Okay, so I need to figure out what number goes up here. And the number that goes up here is A times C. So I'll remind you, A times C. So that's x squared times negative 36. And I'm grabbing the whole thing, not just A. So that's negative, oops. That's negative 36x squared, right? So if you're wondering, this yellow goes right here. This green goes right here. And then the B term, our middle term, is, oops, this B term is going to go down here. So that's negative 5x squared. Okay. And so here we're going to come up with the same question, right? So it says what times what gives me, and this is going to be negative 36x squared. And then what plus what gives me negative 5x. Why does that say squared? Let me erase. Can I erase? Nope. There you go. So why does that say a negative 5x? So what times what gives me negative 36x squared, and what plus what gives me negative 5x? And so some of you already have answers in the chat. That's awesome. So in reality, if you don't know how to do this, I factor that 36. So I'm going to take 36 and write all the factors of it. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And part of being a mathematician is knowing that you've written all of them. So I came up with, if I just start counting, 1, 2, 3, 4, not 5, 6, right? And then if I say 6, that just pushes me over to the other side. Okay, so the question now is going to be, well, which one of these pairs is my winner, chicken dinner? That would multiply to give me negative 36x squared, but at the same time, add to give me negative 5x. I'm going to have you think about that really quick while I help something. So then some of you already said the answer and you're right. It's the 9 and the 4. In case you don't know why it's 9 and 4, it's because it's the only set that will give me a 5. Okay, if I added these two together or subtracted, I can't get a 5. Same with 2 and 18, same with 3 and 12, but I can get a negative 5 if I say 4 minus 9. So that this pair here is going to be my pair that goes over here, and then eventually over here and over here, right? So it's going to show up here and here and here and here. So one more time, I put 4x, I put negative 9x. You guys all comfortable with that? And then I'll check. 4x times negative 9x. Oh, that's negative 36x squared. Check. 4x minus 9x is negative 5x. Does everybody see why this has to be the answer? Right? Has to be the answer. It cannot be anything else. Everybody comfortable with that? Okay, now if you're one of the ones that are like, oh, Ms. Johnson, I wouldn't be able to do this on my own, don't say that. Number one. Number two, it's just a step. Number one, get your 36, write out all your factors. Then check every single pair to see which one gives you a -5, right? The confidence here is knowing that you've written all the pairs out. So some students get really frustrated with this because they don't do this step and they're like, I could do this in my head, Ms. Johnson. And then they skip a pair and they're like, it doesn't work, Ms. Johnson. It doesn't factor. And I'm like, it does factor. No, it doesn't. I tried all the pairs. I'm like, oh, okay. Did you try 1 and 36? Yeah, I did. 2 and 18? Yeah, I did. 3 and 12? Yeah. 4 and 9? Oh. So if you skip this step and you're frustrated, it's because you skipped this step. Okay. If you're not a strong, factorer, then know that you're not a strong factor and make sure that you use tools to help you in your weakness, because then your weakness becomes your strength, right? All right, moving on. So then I fill in this box here. I already told you that the 4x and the -9x go there. So let me put that. It doesn't matter which one goes where. I can flip-flop these two if I wanted. Okay. What goes in this first box? What goes in this first box? Very good. The first box is that first term, so it is x squared. Okay. What goes in my last box? Oh, so no, not -36x squared. No. The first term literally goes in the first box, and I'll explain why. What goes in my last box? Yeah, my last box is my last term. -36. Very good. Okay. Very good. All right. So here are my terms. Now, if you look at this guy here, I'll circle this guy here and this guy here, right? They're the same. I just broke it up in a different way. Really, Ms. Johnson? These two are the same? Yeah. X squared, x squared. -36, -36. No, Ms. Johnson, they're not the same, right? Because this is a -5x and this is a -9x and a 4x. Yeah, but what's -9x plus 4x? It's a -5x. Very good. Okay, so this one here is going to be your answer. Does it matter where x squared and not really, but I put them in this order because I know what's going to happen next. I tend to leave x squared first term in the first box, last term in the last box. If you switched them up, you would still get the same answer, but it's a little bit switched, like Yoda, how Yoda talks. Okay, so then the next thing, what's the next question I'm going to ask myself? What's the next question I'm going to ask myself? What's the next question I'm going to ask myself? Okay, I have like 4 people participating. I need a couple more people. Yeah. So here you're going to say, what's the biggest thing I could take out of this first row? What's the biggest thing I could take out of this first row? Yeah, one of the best ways that you guys can make sure that you're doing better is by participating. It's not to appease me, trust me. It's to make sure that you know what you know. And if you notice that yourself, you are not participating, it's because you don't understand. It could be because of that. So you're right. The biggest thing that I could take out is an X. Very good. Can you guys practice chatting to the public instead of just to me? I actually know the answer. I know it sounds crazy, but I do. So this is going to be X, right? And then you play who's missing. X times what gives me X squared? Right? X times X. And then X times what gives me 4X. So there's your first factor, X plus 4. right? Okay, next one. X times what gives me negative 9x? There's your other factor. And then your check. Negative 9 times 4. Is it really negative 36? Is it really negative 36? And the answer is yes. Yes, it is. Okay. So very good. So then you would rewrite this as this: x plus 4, x minus 9. So in reality, I took this $20 bill and I broke it up into its parts, a 5 and a 10 and 5 ones. I don't know. However, I broke it up. These two things, their value is the same. They look different. Now, your job is, as a student, your job is to make sure that you look at these two things and say, oh, I see how they're equal. Because, right, as a young human, you would have looked at the $4 or $5 bills and the 120 and be like, no, I'm going to take the four fives because that's way more money. And me and you know that that's not way more money, right? So you should be able to see these two things as equivalent, right, as the same. So how does this help us? You'll see in a second. So this is one way for us to help. And that shows up in your Ready, Set, Goes if you've tried them. Oh, not this Ready, Set, Go. The one before. The week before we had you dividing using factoring. I think it was 3.4. Okay, more on that later. But so now it says factoring works great. Let me make this a tad bigger. Factoring works great for quadratics and a few special cases of other polynomials. Let's look at a more general version of division that is a whole lot looking like when we used to do it with numbers. Let's say we want to divide 1,452 by 12. We would write an analogous polynomial, the division problem, blah, 1,452 divided by 12. You guys all see that? Let's use the division process for the numbers to create a division process for polynomials. Don't panic. In many ways, it's easier with polynomials than with numbers. Start with writing the problem in long division, and then the polynomial needs to have the terms written in descending order. If there's any missing powers, it's easier if you leave a little space for them. So you'd leave like a placeholder. Okay. So then you write it. So here's 1,452 divided by 12 versus x cubed plus 4x squared plus 5x plus 2 but equals x plus 2. Do you guys all see how these are analogous? Everybody's okay with these being analogous? Yes. Yes. Okay, good. So then it says, okay, so can you pause really quick? Go back to 4th grade. How did you start this problem? And they did something like, how many 12s go into 14? Do you guys remember that? How many 12s go into 14? We're going to do the same thing here. We're only going to pay attention to the first term of each of the polynomials, this x and this x cubed. So I say x times what gives me x cubed, or how many x's are in x cubed? And you'd say x squared. Do you guys all remember this? So is this part weird? Why is the 1 an x and 2 isn't? This one? Yeah. So they're just making an analogous problem. So instead of me writing 10 plus 2, I'm writing 1x plus 2. So if you think about it, x is just the powers of 10, right? X is 10. 10 plus 2 is 12. 5x is 50. That's why we have 52. 52. X squared is 100, so that's 400. Get it? It's just an analogous way of looking at it because I'm built. This is why I'm choosing to do this. You know how to do this, right? Do you guys all remember how to do long division, kind of, sort of? Yeah. So I'm going to use what you know to build what you don't know. I'm going to use what you know to build what you don't know, because the phrase that I've been saying over and over again is what? If it works in number land, it should work in polynomial land, right? Okay, so then I say, how many x's go into x cubed? And you say x squared, or x times what gives me x cubed? Do you see your two options here? Same thing goes here. 12. How many 12s go into 14? And you say 1. Or 12 times what would get me close to 14? And you'd say 1. Exactly. X squared times x equals x cubed. Everybody okay with this? Then the next thing that we would do is we would multiply. 1 times 12 is 1,200, right? because of the place that it's in. Really, this is 100. Everybody okay with that? So then you go 1,200, and then we'd subtract. Do you guys remember this? So we're going to do the same thing here. We're going to go x squared times x is x cubed. X squared times 2 is 2x squared. And then we're going to subtract. And you know, Miss Johnson, because she gets all messed up and backwards with subtraction, she's going to distribute that negative out. Okay. She's going to distribute that negative out so it looks more like this. And then when I subtract, it's better. So then you're actually going to subtract. So then we subtract x cubed minus x cubed is 0x cubes, right? 4x squared minus 2x squared is 2x squared. 5x plus 2. Everybody okay with this? Anybody lost on any of these steps? X times what gives me x cubed? X squared. That's not new, Miss Johnson. Wait, is that new? Right? No, this is not new. What about multiplying x squared times x plus 2? Is that new? X squared times x cubed. X squared times 2, 2x cubed. Is that new? Everyone say no, that's not new, Miss Johnson. Well, what about subtracting? Is subtracting new? Everyone says no, Miss Johnson, this is not new. This is not new. This is not new. This right here. Someone asked, where did we get 2x squared? Someone answer him. Where did we get this 2x squared? Good question. Where did this 2x squared come from? Yeah, you multiplied x squared times this whole thing. So this guy here, it comes from x squared times x plus 2. You're just taking this and distributing it here, which is basically what you did here. How did you get this 1,200, right? That's really what you're asking. Where did this 1,200 come from? Or 1,200, where'd you get that from? Does that make sense now? Okay, perfect. So then we subtract, and then what are you going to do? You're going to repeat that process all over again, right? So don't look down here. Don't look at the next step. See if you can come up with what number goes here. What number goes right here? Based on what you just learned, you're basically figuring out, okay, well, what number goes here? And you're like, oh, this is when I ask, how many 12s go in 25? What goes right there? Yes, very good. So someone tell me what goes here. Someone says, I think it's 2x. Someone says, I think it's 2x. So I'm just going to put a plus there and I'm going to put 2x there. How would you know if you were right, Miss Johnson? Well, I knew that I was right up here because I had 0x cubes, right? The x cubed term went away. So how are you going to know if you're right here? Well, can you fill in this part right here? What goes right here? I know the answer is right below, but don't look at it. Just fill in what goes right here. Yeah, I can tell some of you like got this. Not worried about your quiz tomorrow on this. Very good. I mean, not tomorrow, sorry, Wednesday. Did you do it? I have for sure about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people tracking with me. The rest of you, is it because you do understand this? Are you lost? What is happening? I don't know. You got to tell me if you don't get it. All right. So what's my next step? What do I do with this 2x? What do I do with this 2x? What do I do with it? What did you do with this, right? Like how many 12s go into 25? You said 2. What do I do with that 2? Yeah, you multiply it, right? You're going to multiply. So what am I going to do with the 2x? Yeah, you're going to multiply. So multiply out just like we did here. Multiply out. So you're going to multiply 2x times what? Yes, x plus 2. Very good. So put that right there. Do that now. For those of you who are like, I'm lost, you got to do the work that I just said to do. This is like one of those things. Until you get your hands dirty, you're not going to understand it. You're going to keep thinking that this is like one of those things that I really like teaching because it looks so complicated, but in reality, it's not. It's the same thing that you've been doing since 4th grade, except for now I am applying it to polynomials, right? All right. So did you put it in there? What did you get? What did you get? So someone said they got 2x squared plus 4x. Yeah, exactly. This is exactly right. Because look, 2x times x is 2x squared. 2x times 2 is 4x. Then what do we do? What do we do after we multiply? Then what do you do? Okay, so after we multiply over here, let's multiply over here. So that's 24. What do we do next? Yeah, then we basically subtract. Very good. So subtracting for polynomials looks like this. I change everybody's sign. And I cross off like that. Right? So we basically subtract. Now subtract. So any of these steps like, oh my gosh, Ms. Johnson, no, I cannot do that. I cannot multiply, Ms. Johnson. So if you think about this individual steps, okay, because someone said, yeah, we might get lost in the process. That's why you're writing this right next to it. Because if you remember this, then you'll remember this. So if you think about the individual steps, it's old stuff. X times what gives me x cubed? You know that. Multiplying, distributing, old step. Subtracting, old stuff, right? All of this is old. The order in which you do them, that's what's going to get a little bit like, oh, keep track of it. But that's why you put this right next to it and you're like, okay, now what do I do? Oh, and then now I'm going to have to subtract. And then you're not going to need this at all. Very good. So then I'm going to add or subtract down depending on how you phrase it. So that goes away and this is going to be x plus 2. Now here's how I know that 2x deserved to be there because I have 0x squareds left. If you subtract these two and you have an x squared left, that is wrong. You did something wrong. No. Okay. Okay, so now what do we do? Now what are we going to do? So we're right here, right? And we subtract it off and now we have 12 left. What do you do in this case? When you're at this step, what do you do left? What do you have left to do? Yeah, we just divide again because that's what you would do here, right? If you had this 12 right here, what would you do? You'd be like, how many 12s go into 12? And you're like 1. So again, we divide and we say how many x's go into x, or we say x times what gives me x. X times what gives me x, guys? Yeah, it's plus 1. I do put plus 1s here because this is a polynomial, right? Over here, you don't have to put plus because these are all place values, right? So here we're going to go, and then you guys all know what to do. What am I going to do next? Very good. Very good. Go ahead and do that then. So people told you what to do in the chat. Go ahead and do that. I'm just catching up on all of my participation right now. Some of you, you do not participate, and I know what, because I've looked at your work, I know what you're doing. Some of you don't participate. It makes me super darn nervous. I say that out loud because I don't want you to fail. I don't want anybody to fail. I know that seems maybe not what you think about me, but I don't want any of you to fail. Very good. Yeah, just finish up that problem. Go ahead. You guys are all in the chat right now. I'm just trying to catch up. Okay, very good. All right, I think I got everybody. Okay, so then you're going to multiply again, x plus 2. And I'll be honest with you, I don't put x plus 2. I literally just put x and 2. That way I can go in with another color and subtract off. This actually becomes 0. This 0, I told you before, actually means a lot. This 0 actually means a lot. Can you think about if this number, right, because you go minus 12 equals to 0. If this number was not a 0, what did that mean for these numbers up here? Anybody remember? Yeah, very good. Very, very good. So, so here, because this is 0, yeah, if this number was like a, say, a 2, that would be like back in 4th grade or 3rd grade, you'd say remainder 2. That actually means something over here, right? It actually means that, well, if you had a remainder, like let's just do a simple one, like 5 divided by 2, right? And you're like, oh, that's 2, and then this would be 4, subtract would be 1. So this remainder 1 actually means something about, and it tells me about this 2 and this 5. Because it has a remainder, it means something. It's pretty interesting. So that same meaning over here, we can carry that over here. I'm not going to tell you right now because I want you to think about it. I'm planting a seed. So it'll start, you'll start thinking about, what does she mean? Like, what is that? That tells me something. What does that tell me? Okay. So those are questions I want you to think about. All right. And then, so here you notice, boom, 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 it's all done. So it says, in this case, 1,452 divided by 12 leaves no remainder. So then we say that 12 is a factor of 1,452. Ta-da, that's what I wanted you to know. Similarly, because this has a 0 as what's left over, has no remainder, it means that x plus 2 is a factor of x cubed plus 4x squared plus 5x plus 2. Okay, this is so important that they gave this, they have a couple of theorems that are attached to this thought right here. There's the remainder theorem, there's another theorem that I can't remember off the top of my head right now. So similarly, this polynomial divided by x plus 3 leaves no remainder. We would say that x plus 2 is a factor of this. Polynomial division doesn't always match up perfectly to analogous whole number problem, but it's a process that we can use. Okay, we're going to use it. So here, I want you to try this. I'm going to pause the video right now. You're going to try this one completely on your own. Okay, they give you step-by-step work here. For those of you who don't need those steps, just kind of leave this space right here and do the number on the left side and the number on the right side. And I want you to just be able to do that. Okay, so just first set it up. So I'm going to set it up with you. I'm going to make sure that I don't copy it wrong either, because and then I'm going to need more room because, you know, Ms. Johnson, she writes big. So I'm going to write it off to the side. So we got x cubed plus 3x squared. Ooh, I want to do this thing again, because whenever I have these lines, it helps me. Okay, so x cubed plus 3x squared minus 13x plus 15 divided by x minus 1. Okay, so I want you to do this right now. Go ahead and try this out yourself. If you're done with this one, do this one as well. We're going to come back in a little bit and check how well you did. Okay, before I let you go and do that, I want to remind you how you used to check your answer over here. Does anybody remember how they would check their answer over here? How would you check your answer over here? Yes, very good. How do you check 1,452 divided by 12 is actually 121? You multiply. So let me ask that same question. Similarly, how would you check your answer over here? Yes. Yes. Exactly. So how would I check my answer? I would multiply as well. I would multiply this by this. Can you imagine that gigantic area model, right? If I multiplied that out. So during a test, right? I want every single answer correct, right? So I would make a gigantic box like this. I would put x plus 2 here, and I put x cubed. Oops, not x cubed, sorry. X squared plus 2x plus 1. And then someone asked in the chat, Miss Johnson, if I multiply 121 by 12, I'm supposed to get the dividend, correct? The guy inside the big number. Yes. Same thing goes here. If I multiply x plus 2 times x squared plus 2x plus 1, then I'm multiplying this out here. Very good. Anybody know a different way to check my answer? Anybody know a different way to check my answer? I'll give you a hint. It's using my best friend. Who's my best friend? By the way, Desmos is not really my best friend. I just like to say that so that you guys remember, like, oh yes, use that. So I'm actually going to write this all out as a division problem, but I'm going to use parentheses to let Desmos know I want all of this, right? So I'm going to go x to the third plus 4x squared. Does everybody see what I'm doing? Plus 5x plus 2. And then I'm going to go divided by. Oh, it's not going to let me put divided by. Okay, divided by. I'll do that. It's going to look like a fraction. I was hoping that it would look like the division symbol, but who cares? And then I'm going to put the whole denominator in parentheses too. Okay, it gives me this parabola, which is a really good sign because my answer is a parabola, right? And then I'm going to plug in my answer. And what am I hoping? Anybody know what I'm hoping? What am I hoping for when I click this last number? Yes, I'm hoping for them to overlap. Where did my red one go? And then I unclick my blue one. There he is. They are the same, right? So this is how to check it graphically with it, right? And so just know that on a quiz, because I just showed you how to do this, right? And how to check your answer. I am also looking for all this beautiful work that you're going to give me. Okay. All right. Okay. So with that being said, you're going to divide this and you're going to divide this and you're going to come back to me. Okay. I'm going to pause. Okay. So we're going to continue on. So the division part, when we're dividing, you're going to literally follow these steps. Otherwise, if you don't follow those steps, you're just going to divide like just normal division. And you can use any number. It doesn't have to be this particular, like the analogous number to this. So, especially because this says 13, just look at the structure of what you're doing. And so because I'm looking at a structure, I'm just going to go with, I don't know, 1,000 divided by 5, just so that I can remember my steps as I go. So what's the first step that I need to do here, folks? So the first step, yeah, how many x's go into x cubed, or x times what gives me x cubed? And we're going to say x squared. So then after I put x squared here, then what do I do? Yeah, then we multiply, and you're almost like distributing x squared. You not almost exactly. You are exactly distributing x squared times this whole thing here. And then remember, I don't put signs in unless it's negative, so I can change the sign, when I subtract. So x squared times x is x cubed, and then I just line him up with his like term. And x squared times -1, well, that's negative x squared, so that goes here. So that's a minus x squared. And then I go in and I change my signs. I subtract, right? So then that becomes 4x squared minus 13x plus 15. And some of you are like, hey, Ms. Johnson, how come we only brought down like 1 0 at a time? I mean, you can bring down the whole thing if you want. You can bring down just negative 13x if you want as well. So then the next step is you're just going to repeat. So x times what gives me 4x squared? It's going to show up. It's just a little laggy, right? Let's make it less laggy. Very good. Okay. So x times what gives me 4x squared? And you guys all are like, oh, 4x, Miss Johnson. Very good. And then I distribute again. So 4x times all this would be 4x squared minus 4x, right? And then I go through and I change my signs because I'm subtracting. So here I get negative 9x plus 15. Everybody with me so far? Check Miss Johnson, because sometimes, wait, isn't it negative 3x squared? Where? Where did I mess up? Did I mess up somewhere? It says wait, isn't it negative 3x squared? So I got, oh, did I copy the problem wrong? Is that what I did wrong? No. Yes, I copied the problem wrong. Ugh, this is why, Miss Johnson. Okay, so negative 3x squared plus x squared. Oh, boo, Miss Johnson. Okay, thank you for catching my mistake. Let me just fix everything. Were you guys freaking out? Like, wait, mine is wrong. Oh, great. Let's see. So this would be negative 2x squared, right? Yeah. Oh, wait. Sorry. If you copied wrong like me, just check your answer. I just want to make sure that I do this one. Okay, let's go back over here. Let's see, x cubed minus 3x squared minus 13x plus 15. I copy things wrong all the time. So negative 2x squared. So this is minus 13. Okay, so back on track. So x times what would give me negative 2x squared? Yeah, minus 2x, right? Then negative 2x times that, it would be negative 2x squared plus 2x. But I'm not going to put that plus there because in a second, I'm going to go through and change my signs to positives and negatives, right? I just change. For if it's negative, now it's positive. If it was positive, now it's negative, right? So then this is 15x, negative 15x plus 15, right? And then I say, okay, x times what gives me negative 15x? You all would say negative 15. And so this is negative 15x and 15. And then I go through and I change my signs. And this is 0. Again, this 0 means something, right? What does this 0 mean? There's no remainder. What does the no remainder mean? Very good. This is a factor. Technically, this is a factor. I probably can factor this a little bit more, but right now it's a factor of this polynomial. No remainders means that the divisor is a factor. Very good. So we did that. We're all good. Miss Johnson, she messed up because she copied it wrong. So now some of you are looking at this like, no, Miss Johnson, there's a 2 in the front. How is that going to change? Or it's not going to change anything. Okay. So now instead of you dividing by 10 or 15, now you're dividing by 20 something. It's still the same thing. Okay. Still the same. So you should be able to do this one, and I'm going to leave that to you. It says when dividing numbers, there are several ways to deal with the remainder. Sometimes we just write the remainder like this, right? Do you remember this? You would write 8 remainder 1. Do you guys remember that? Because 3 times 8 plus 1 equals 25, right? Sometimes we would write it with the divisor as our denominator, right? I'll say that again, our divisor as the denominator, right? And we're going to do the same thing with fractions as well. So when you divide this one, there's going to be a remainder. Because this is a remainder, it indicates this thing is not a factor. Okay. So, and the only reason why I know that is because it says it here, it's a remainder 15. Okay. So there's 2 ways for you to write it. Number 1, here's one of them. Look where this is. He's your divisor. Look where this is. This is your answer. You multiply those 2 and then you add your remainder and you get back to your original function. So when I was showing you how to check it before, it's really easy when it's a factor. When it's not a factor, it's not that different. You just have to remember that 15 right here. Or you can add it like this. Now this one looks funny. So here's my divisor. There's my divisor. Here's x squared plus 2x minus 2, x squared plus 2x minus 2. Now, where did this guy come from? Where did this guy come from? Now, you're going to use your amazing young skills, right? You're using your young eye skills and you're looking for, where'd that 15 come from? And you're like, oh, that's the remainder. Wait. Where'd that 2x plus 3 come from? And you're like, oh, that's the divisor. Became my denominator. Okay. So you are now ready to do everything. Here's another practice. Here's another practice. Here's another practice. They actually want you to write it. So divide each one and then write 2 multiplication statements that go with it. So they're really interested in you writing it like this. Again, rewriting it. So I want you to try these as well. And then let me pause this video here.